Okay, I'm just going to go over this problem with you for the people that are gone and the people that are here because I am gone. So I'm looking just at the worksheet that I gave you. The first thing I'm going to talk about is flip over and look at your limits. And the first two problems, all you're doing is using substitution to find the limit. The next four problems, all you're doing is, if you substitute it in right now, the denominator would equal 0. So what you have to do is factor first, and then substitute the value in. And then the last part is, you're going to just put it into your calculator, and you're going to look to see what happens as it's getting closer and closer to 0 or infinity. And then the answer's down at the bottom. The other side now, I've seen this on the AP test, and we haven't gone over one of these, so I want to go over one of these. So here's the chart up above. I just want to explain the chart. There's an x equals 1 and an x equals a negative 2, so depending on which one they want you to do in the problem, you're going to decide to look at either the first row or the second row. If you scan your problems, you can see that some are at x equals 1 and some are at x equals a negative 2, so it depends on which problem. This is x, this is f of x, obviously the derivative, and then g of x, and then the derivative. So all you're doing is finding the derivative of all the problems, and then after you find the derivative, you're going to use the chart to figure out the answer. So here we go. I don't like the way the first one is written. Remember how we did derivatives of trig functions? I'm going to do it over here. I don't like the sign of 2x. That's not the way you plug it into your calculator anyway. You would have to plug it into your calculator, the whole thing squared. And that's similar to this problem. I don't like this one because the whole thing is squared. So what I want to do is rewrite it. I guess I already rewrote it. I just know it. It was here. It was there in the problem. And I'm going to put it way on the outside so the whole thing is squared, because I need to use the chain rule for this. Okay, so the only thing I did was I changed the 2 to the outside, and now I'm going to find the derivative. So to find the derivative of this one, I take the 2 and I put it out in front. I'm using the chain rule. I'm leaving the inside alone, and I'm going to change the 2 to a 1. After you leave the inside alone, you also have to take the derivative of the inside, and the derivative of f of x is f prime of x. Now we're going to do the second one, negative. The 3 is just a constant. All you do is drag it down, just like integration, just like derivatives, you drag the constant down. Okay, now this problem, if you look at it, do you notice where the squared is located? It's located on the inside of the function. So all you're doing is finding the derivative of x squared, and the derivative of x squared is 2x. All of this is at x equals 1. So I'm going to be looking at this row to help me solve my problem. So all I'm going to do is substitute now. 2 at 1 f of x is at 1 f of x is 1. So in place of f of x, I'm going to put 1. And then I'm going to look above and say f prime of x is 3 minus 3. And then you're looking at the g now. Do you notice that the first one was an f and the second one was a g? So you need to look at the g, and you need to look at the derivative of g. I should have a little g there. What's the derivative of g of x squared? G of 2x. I just kind of, you should put that little g in there. And then now at x equals 1, the g is a negative 2. And then, if I just finish this, 2 times 1 times 3 is 6, and a negative of a negative equals a positive, so 6 plus 6 equals 12. The next problem I'm looking at is problem number 2, and I'm giving you hints on how to solve it. If you have f of x times g of x, you need to use the product rule to solve this problem. Mu v prime plus v u prime. So see what you can do on the next couple problems. You're either using the product rule or the chain rule, and it looks like most of them are the chain rule. So um, I might be back before the end of the hour.